I would yell, but I have done it before too. I've forgotten to. All right, so it is sharing. Did it start? Yeah, yeah, it started. The broadcast has started. So I'm going to bring up the virtual machine. And now I have to log in again. So what I want to do today, as I said, talk a little bit about SQL. Let me bring up the SQL Server. It's interesting. You have to do Microsoft before. It used to be just SQL would bring it up. Yeah, I guess. Didn't they buy Skype?
They did. They now own LinkedIn.com. Oh, yeah, they.
Come on, open. And I may zoom a little on this. Also, I've been meaning to do this. Although this is one of the last times we're going to be using SQL Server, because then we'll be moving over to MySQL. But this is really hard to read even for me. I'm going to pin it to the window though. And then if you, it'll always be there, right? Let me zoom up. Okay, that looks fairly sharp. Is it to you guys?
Yeah.
So one of the things I'm going to do is I'm going to bring in a database to test, to do the SQL on. And it's going to be the Community Assist. And I'm going to show you how to get it. You don't have to have it if you just want to watch, but if you want to follow along, you might want to have it.
Okay.
So what I'm going to do is I'm going to go to the internet. And what I want is github.com. So I'm going to do http://github with a I, github.com, and it's GitHub SP Conger. All right, so it's my GitHub repository. If you ever want to go there, there's hundreds of, well, not hundreds, how many? There's 91 repositories of various codes, some of it Python, some of it SQL, a lot of it C# and a little bit of Java. So there's a bunch of stuff there. So we want the one that's right. Notice how popular it is because every class has to download from here. I've got database schema. And, oh, I'm not signed. Well, I don't need to be signed up. All right, so let's go down here. We want Community Assist SQL, not the 2017 one. I'm working on it. I'm trying to make it a little bit more coherent than this one. I'm making some changes to it, but this one has the data in it. Community Assist SQL. Yeah, the 2017 I'm right now in process. It's a new version of this, yeah.
How do we find your repository?
So it should be just GitHub spconger /spconger. And then it should be database schema. So you want to click on that, and it'll give you basically a whole bunch of SQL database code, a lot more than we're going to do. But you don't want to copy it this way. You want to go to raw. The reason you don't want to copy it is all that neat color coding and stuff that GitHub does, when you paste it into SQL Server, you get all the HTML code, and it's just a big piece of garbage as far as SQL Server is concerned. But if you go to raw, you get the plain text. And what you want to do is to copy it all. So I'm going to do Control A to select it all, Control C to copy. You can use whatever, if you prefer to mouse through it, you can. I'll go through this again if you want, but this is just, again, this isn't a necessity, but if you want to follow along on the examples. I didn't create the Vince's, which I should do, I suppose, and provide some data. But so I'm going to do Control V, which is paste, or you could just right click and do paste. And basically, it'll go through and it'll create everything. It'll add all the data. You don't have to pay attention to any of the SQL unless you're really interested. So I'm going to go to the top, although you don't have to do that. If you have a copy of Community Assist like I do right now, the very first thing it'll do is get rid of it. And then it'll make it again. So you can always go back to the original state. Of course, you lose any changes you made, right? But that's fine. I haven't made any changes. So I'll run this again. When you execute it, it should, at the bottom end, come up with this. These are all the rows that have been inserted. Right? The database won't show up over here unless you right-click on databases. Mine's there because it was there before, and do refresh. You don't have to keep the script unless you just want to look at it, because it does give you a lot about just basic SQL. Yeah. No, don't get the 2017. I'm working on the 2017. It doesn't have that much data in it. I think I'm going to use it for classes in the winter. So while this screen is up, do you guys need me to go through that process again?
Yes, could you please?
Okay. I will kill this. And I'm also going to delete it here. See, so it's gone now. All right, so in the web, go to GitHub. So let's go back. Yeah, so you want to go to github.com/spconger. So I said that's my repository. There is out there somewhere, there's a Steve Conger, but there isn't an SP Conger. So yeah, I have done Steve Conger, and it occasionally gets confused. So I usually do SP. That's my middle initial. So the very first repository under popular repositories is database schema. So you click into that. Down below here, you'll see a whole bunch of different things. And we could do, so let's do Community Assist SQL, not the 2017.
Are we doing this one? Now you said we are doing 2017.
No, don't do 2017.
I'm sorry.
Do not restart now. So let's, never isn't an option. At least it gave me a time. All right, so when you open the Community Assist, over here there's a button called Raw. Click on that. Again, because if you paste it with all of the color codes and stuff, it won't work. So if I'm just going to do select all, I right click to do select all, and then I'll Does it right click again? Control C to copy. All right, once I've got it copied, can come here and you can do new query. I'm going to paste it. So one of the things you can do if you want is you could right click paste, or you can just do Control V. You don't have to go to the top, but I will. It's at the bottom by default after you do this. So we are going to execute, and once it executes, you'll see that there are all these rows that it is inserted, and it's also created all the tables and things. If I go to databases, it doesn't show up there, but if I right click on databases and do refresh, Community Assist will be there, and as you open it, you'll see that it has all the tables, and all the tables have data. That's a neat thing about SQL. It's fairly easy to move a database around if it's small, right? If there's a lot of data, you can't script all the data. I did it to one that I had made that had like 500,000 rows in some tables, and it was like 1,200 pages long if you were to print it out. And when you tried to load it into memory, because it has to load the whole thing, it would crash. So you can't always, script all the data, but you can usually script the structures of the tables and things. Like this. And so you can script the structure of the tables. Like this is create table. Remember, we kind of looked at that. And I'll show you, you can generate a script like this by right-clicking on a database, going to tasks, generate scripts. You can actually have it write out the script for the database. In that, you have a choice of whether to add the data or not. And if it's a very big database, I would say no. So when it adds data, that's where you get down to all these insert statements, where it inserts each row of data. We'll talk about that a little bit today.
Is this script generating when you make a new database from like the table format? I mean, is the script kind of
everything you do in the designer has an SQL underneath. Does that make sense? So let's. I'm going to close this. Unless you want it open, do you guys need it for anything? You don't have to save the script once you've run it, unless So I'm not going to save it, but I'll show you how to generate a script. This is a good way to take things home also. I showed you how to detach files. This is the other way you can do it. So I'm going to do tasks. Notice it says script database. That you don't need to do. That will only script the create database. I didn't show you, but I will. Every single dialog in here has a little button that says generate SQL script. So we're going to talk a little bit about SQL, but I'll show you this. I'm going to do generate scripts. And it gives me a wizard. First one is just a splash screen, so you can take that. It says, what do you want to script? We're going to script the entire database and all database objects. You can have, if you want, you can choose what you want to script, right? So on this one, yeah, right-click on tasks, and then database. I can take you through this again later, but this is just a show. This is where do you want it to go? This is going to go to a file, but you could change it to the query window, which I'm doing there. This is where you choose whether to have data or not, is in the advanced. There's lots of options there. One of the options down at the first break, it says types of data to script, schema only. Schema in this context means the structure of the tables, right? So it's going to, at this point, script only the structure of the tables, it'll make all the create table statements with all the fields and all that, but it won't put any data in there. If you wanted to have data, you can do schema and data. Again, if it's a big database, that's a bad idea. So I'm going to do OK there. I'm going to do next. Gives me basically a confirmation. Is this really what you want? If it isn't, you can go previous. I'm going to do next. And it will print. It'll go through this and generate all the scripts. I'm going to finish. Now, the one thing I would say about this is there's a lot of this I cut out. These are all defaults. The path names could give you trouble. These are a path where the files go. If it's different on your machine, it'll fail. So, not that it really matters, but I'm going to cut from here. Oh. Down to here. And then it'll build in anything. Once you get rid of the specific paths and all those altered databases, we're just putting in the defaults anyway. So, and in the path, you just don't want the path. And if you don't write the path, it'll just go to the default path for your machine. Otherwise, it'll try to find that path, and if it's different on your machine, it won't work. So I usually do this before I post them. Sometimes I write them. When I create the database, I usually create it by hand, by script. That's how I prefer to create a database. So let me talk a little. How many of you have ever used SQL? You have. You're the only one. Yeah, you were in the class. So SQL is not a hard language. In fact, so we have Community Assist here. I'm going to open a new query. What? So we got it from. Right, but that's the wrong. Let's go back and get. Not the 27th. Just go back.
I didn't get how to do the script. I couldn't find the path. I couldn't find the path. Generate script. Script inside database.
Yes.
Which is fine.
And then he sent it to Sesbert. Steve,
Yeah.
what was it that you had cut out of here? Was it from here up?
I cut from actually all the way down, all the way down to use community.
Okay, that's what I thought.
But not everything. You want to leave in the create database.
Okay, so up to here.
Actually, get rid of the up to create database. Up to leave create database. Although, again, you can get this on GitHub anytime.
Still, I want to know this.
Yeah. So I'm going to show you just a little bit. I'm going to just say use Community Assist. And in SQL Server, there is some IntelliSense. So I can just click that. And if I run that statement, and the way you run it is you click the little triangle. That's how you had to run the other script too. It says command completed successfully. You can also notice that it says Community Assist over here. Right, so you need to be in context. And this is true with a lot of, this is true even in MySQL or whatever, because a server like this can have many databases. We've got several on here. We've got Community Assist. I've got part of Vincent's. I've got test 1, test 2. I mean, each server can have many databases, so it needs to know which one you want to talk to. In most environments, as I've said before, this would end with a semicolon. SQL Server ignores the semicolons, but they're required in other environments.
How did you get that on new sheet? Is it a new sheet?
Just new query. You can also on a database. So if I were to go to Community Assist and right click, I can also get new query there. So I'm just going to say select person last name, person first name, person email, from person. Okay. Those red lines go away once it knows what the table is. So I'm selecting 3 columns from the table person. The word that after select, what you do is you list column names. After the from, you list person. I mean the table name. And if you look, how did I get those? I just know this, but if you look under person over here, I'm trying to go down, and you do columns. Notice it has person last name, person first name, person email. So they have to match what you type up here. If I select that one, I'll run just it, and I can execute. And down below, it'll give me the last name, first name, and the email. Okay. So a couple of things just to say about SQL. And again, in other contexts, this would have. So this is sort of the basic query. There's a select, what you want to select from the table, and the name of the table. We're going to talk about joining tables in a little bit. You guys got it so far? It's fairly English-like, right? We want to select these things from this table, which is fairly simple. SQL is considered a 4th generation language. Does anybody know what that means? Well, it's, what would you think?
Renditions of programming?
Yeah, so what's a 1st generation? Anybody have an idea? Even before assembly, machine language, right? The original 0s and 1s. Switches on, switches off. That's 1st generation. 2nd generation is assembly, right? Because you have verbal cues to the switches, basically. Assembly is really close to switches on and off, but it gives you verbal clues. You know, a command in assembly could take 40, 50 lines to do something like print something on the screen, because you have to go locate the memory address. You have to give it the command to copy that to another position. You have to tell it to go to the video card. You have to tell it to move it up to the monitor. You have to tell it basically what pixels to light. You know, it's a lot of commands. So 3rd generation languages, anybody have a guess what those are? Pretty much anything you've ever thought of as a programming language, probably. C++, C, Java, Python, R, yeah, all of those languages, yeah.
I have some buddies that say that CSS and HTML isn't a programming language.
I would somewhat agree with them. I would say that they're just markup languages, because they're not compiled into machine language. Actually, at some point they probably are.
So
But
does that mean they're 4?
they're what?
Does that mean they're 4?
Well, I wouldn't say that. I think they're something different. They're like a tag. They're markup that you put tags around things to say what markup will be. At some point, they are compiled, though. They have to be. right? Something has to compile them into machine language or the computer wouldn't understand them. Computers, by the way, they don't understand C++, they don't understand Java. You know, it all gets turned into machine language underneath. What makes this a fourth generation language, and that's why I think that the others, I'm not sure, I'd have to think about that, is that in SQL, you do not have to tell it how to do something. You just have to say what it is you want done, right? I just want to select these things. If you were to do this in, say, Java or C++, you'd have to go find the file. You would have to pull the data out of it that you want. You would have to loop through it to determine what you want to display, right, to get the values, and then print them out. So you'd have to go through a series of steps to get this done. You have to say how to do it. They're called procedural languages. You tell it how to proceed step by step. Here you don't have to do that. You just have to say, I want to select these fields from this table. You're saying what you want to do, not how to do it. Does that make sense? That's what makes it a fourth. Other fourth generation things are where there are elements in like C# or Java and things where you can drag and drop things. So, and it generates the code for you. Underneath, not that it matters, underneath SQL is C++, doing all the procedural things that we're not having to do with these. But it's a fairly easy language on its initial stages. It's fairly English-like, and it is always in English. I have a Japanese textbook of SQL, and all the commands are in English, even though the text is in Japanese. The other things about SQL, and this is universally true, are it is not case sensitive. There is sort of a convention, which I don't follow in this environment because I'm lazy, where all of the command words are in caps, all caps. So select would be in all caps. The blue words are the command words. As I said, I'm lazy. But even though it's a convention, it doesn't matter. Even on Unix, SQL is not case sensitive. Most languages are. SQL Server is not. You can break things space-wise wherever you want. So if you preferred something like this, you could. What else do I want to say about it? It's an ANSI standard. Do you guys know what that means? I think I mentioned it once. It's the American National Standards Institute. It's also a international, what is it? IS, is that right? International Standards, ISO, International Standards Organization. So it's an international and a national standard. What that means is anybody that implements a database, a relational database, has to meet certain standards of what SQL is. It's 90% the same across all platforms. So this statement, the way it is right here, would work perfectly fine in MySQL. It'll work perfectly fine in Oracle. It'll work perfectly fine in Postgres. It'll work perfectly fine in any relational database. Does that make sense? And all relational databases have SQL. It's the common language of all relational databases. What else would I say about it? So I said it's 90% the same. One of the things that the standards don't, they say you can implement these, but they don't say you can't add to it. And almost every company, every relational database adds stuff to it. Also, the standard basically says you need to have an int and a float and a character type. And SQL Server has, what, 15 or so integer types. And so you can expand on those types. But it's not hard. So this is how, basically you can, the most basic statement is just a select what columns you want to see in the order you want to see them from whatever table, right? And there's commas here and no comma at the end of the list. Most of the time, and this is true of all programming languages, I think, the things that'll give you fits are where the commas go. Here's another version of this. So I'm going to do select star from person. What do you think the asterisk does there? Right, it's just going to return all the columns. And you have no say about what order. If you list the columns, you can bring them back in any order you want. But if you just do an asterisk, it's just going to bring back everything. You like the hash passwords? They're kind of fun. All right. So this is good for like testing or just seeing what's in a table. It's not particularly good if you're doing programming like with a web page or something. You should explicitly state your columns for a couple of reasons. One, they might have changed the database underneath you when you're doing it, so it might come back with something different. Second of all, this takes a little bit more time because it has to do 2 queries. The first query is to figure out what the column names are, and then the second query is to return them. Does that make sense? So it's slightly less efficient. Okay. So notice that these are, and just go down here, we got Anderson, Zimmerman, Mann. I'm going to show you how to sort them a little bit. Yeah.
Is the language going to be the same all throughout the very different?
Except for the NoSQL. So when we do the Mongo at the end, Mongo uses not SQL because it's not a relational database. It uses JSON, so JavaScript. I wanted to, as I said, the two relational, all relational databases are more or less similar. NoSQL is different. Other questions? That's a good question. Yeah, that hall is so noisy. All right, so I'm going to do sort. Oh, and if you want to do a comment, it's 2 dashes, which is weird, but that's SQL. I'm used to doing double slashes or pound signs or lots of other things, but only SQL, as far as I know, uses 2 dashes. So I'm going to do, actually, I'm just going to copy the first one. I'm going to bring those back up just for screen purposes. And instead of, I'm just going to say order by, and we'll do person last name. And I will execute that. Notice if you select something, it only executes that one thing. Right.
Is the commenting syntax the same throughout all the database?
The which?
Like the commenting syntax?
Pretty much. The other kind of comment you can do, let's do it right at the top, is you can do this kind of comment, which is actually fairly typical. I don't know what I want to say. What is today? 10/23. Okay, and then you can close that like that. That's a typical, that's a C comment, basically. It's a multi-line comment too, whereas these have to be a single line comment. Those are the only 2 kinds of comments that I know of in any SQL. All right, so this one, when we run it, we already did. Let's go down here. You'll see that they're in alphabetical order by last name. Right? Order by does that. It sorts it by whatever column we did. Now, if I did first name as well, then it would have a secondary sort by first name. So if I run this, F5 also runs for those of you that don't like mice. It's still all first primary sort here. And notice there's 2 browns, and it goes LM, right? So those are in alphabetical order too, but within the as a subsort. That subsort can be really useful if you're doing like city, and then you want all of the people within a city. So you could do a primary sort by city and a secondary sort by the last name in the city or whatever. That makes sense. I mean, it's a really useful to do that. These are both A to Z, and if it's a number, it's going to be 0 to whatever, you know, lowest to highest. You can change that by adding a keyword, DESC, for descending. So now it starts with Z and goes backwards, right? If I were to put the, if I were to do comma first name, what would the first name sort be? Anybody know?
Ascending.
It's still ascending. So it would be by last name, you know, Z to A, but by first name A to Z within the group, subgroup. So if you wanted it to descend to, you'd have to do like that, right? You'd have to put it on both. Otherwise, the default is always ascending, and it only applies to the one column you put it after. And if I were to just do person last name, comma, person first name descending, it would only be first name that was descending. So those are sorts. Questions on those? I'm just showing you a little. And I'm going to show you some query.
I'm sorry, I'm a little confused.
Sure.
So if we sort descending last name, that's going to start with Z.
Right.
And then if you add a second column, person first name descending, will it break up the records?
No, it's still going to be Z first.
Oh.
It's still going to be the last name first. So if we go down, do we have any? We have 3 Tanners, right?
Yeah.
And so right now they're in, are they sorted at all? So Tanner, Nathan, Chelsea, but Thomas. Why is, so let's do, oh, you know, I probably didn't run it with first name. Let's run it with the first name in descending, and we'll run it with first name ascending. So now it's Thomas, Nathan, Chelsea, because now it's descending. And then if I were to take this off, because I think the first time I ran it with just the last name. In which case it just puts them in the order that they are in the table. So now it's still Tanner, you know, we're still going Z to Tanner, but now they're A, B, C, you know, in the first name column. But this is still the primary sort. One of the things about databases is it doesn't matter what order you put the data in. It's really irrelevant what order the data is in the tables. And one of the reasons for that is you can always bring them back in whatever order you want. Does that make sense? Okay. You guys got the sort down somewhat? As I said, I'm just going to give you a real kind of what you need for the assignment. So those are sorts. Let's do a little bit of what, you know, right now we're returning all the rows. No matter what we're doing, whether we're sorting or not, we're returning all the rows. We're not necessarily returning all the columns, right? You could list them all, or you could do the asterisk to bring them all to columns. But let's make a decision what rows to return. So we have 3 tanners. Let's do, I'm going to basically just do these same 3 fields again. And I'm going to say from person. And then I'm going to add another clause, which is a where person last name equals, and I'm going to do Tanner, because I know we have 3 of those. And if I run that, it'll bring back just those 3 names, right? So a couple of things about that. Notice the single quotes. When you're recalling character types, you need to have single quotes around it. And it has to be single, it won't be double. Yeah.
Would you be able to do that with just the letter? To bring back all the last names with like the letter?
If you want to do that, okay, let's do that. So just the letter T or something. It's a little bit different. So instead of equal, I'm going to say like. And instead of just Tanner like that, I'm going to do T %. All right, so like is an operator that says to search for a pattern. The % is a wildcard, meaning any number of characters. You can also use an underscore if you're just looking for one character, but the % is an operator for any number of characters. So when I execute that, it brings back all of the last names that begin with T. Does that make sense? Okay. So I want to show you how to bring back some other kinds of data, and then I'll show you how to join tables. So you can bring stuff back from other tables, more than one, and then I'll show you a real quick way to, insert, update, and delete. Is this making sense? It's not too hard, yeah. What do you need to see? So the big key here is equal sign and 2 single quotes. All the values are pretty much have to be in single quotes except numbers. So let's go, I'm going to do a different table. I'm going to select star from donation. And I'm going to do it first partially just to see what's there. So basically we've got the donation key, the person key, which ties it to the person, the date of the donation amount, and the donation confirmation, which we're not going to query because that's just too much of a pain to type in. It basically I had to generate an automatic number like you give somebody a number to show that they donated, that they can use to retrieve the information, etc. Anyway, never mind that. So let's query these numbers. One, you could sort them, right? You could sort them by order by donation amount. And I'll do it descending so that you can see all of the highest donation. Right? And there's a few there with 2,000, etc. Let's say we only want to see the donations that are greater than 1,000. So I'm going to do, let's do the same thing, but I'm going to add right above this, where donation amount greater than 1,000. And then if I run that, it gives me only the ones greater than 1,000, right? And if we wanted to include 1,000, we could put an equal in there and execute that, and it would include the 1,000. So just as I'm going to put this in a comment, you have all these operators, right? You have equal. You have, they're actually, this does allow not equal. However, that isn't standard SQL. Standard SQL uses the not keyword. It will also accept that as not. And again, that's not standard. And then it will do, so then we've got greater than, less than, greater than equal, less than equal. So you have all those operators for just figuring out numbers. They only work on, they actually do work on characters, but the result is not really predictable because what it does is it'll convert the character type into a number based on the ASCII values of the characters. Does that make sense? So it's a little bit weird, but it does sort of work on those. Notice also I didn't quote the numbers. You don't have to quote the numbers. I'm going to do one other, real quickly, I'm going to just look at the whole data set again. So most of my dates are the same. That's one of the things I want to change in the new one. So there's some on 2015, 08, 09. There's a few different days.
Your two characters, what do they mean?
What do you mean?
The third option.
This?
Yeah.
Not.
Not.
The other way to do not is like we could reverse this by saying not. And what it would do is it would return everything less than, basically, which is a bit inefficient because we're just negating the. So it returns everything basically that's less than 1,000 because I said not to return everything greater than or equal to. So not is a valid operator for that. And also all the Boolean operators, there's and there's or, right? You can do those, and they just use the words for them. Let's do, I want to show one other operator real quickly, and then let's do a date. That's what I was trying to look here. I'm going to say select star from donation. And I'm just doing the asterisk because I'm lazy here. Don't want to type in the fields. Where donation date equals, actually first let's just do a date. So I'm going to do, and I want to show you a problem that can happen. 2015, I'm just trying to do the first one. 08, and so 11. And these should have single quotes, not double. All right, so that's the date. But it may not show me anything on that actual date. See, I get nothing. Anybody know why? No, the format's all right. No, actually, what the problem is that I didn't use just date. I used date time. And if you don't enter the time, when you have date time, it assumes 00, colon 00, colon 00. All of these have a later time than that. So they will not show up. That doesn't happen if you use just date. But if you're using date time, the date time gets involved in the calculation. So I'm going to try.
The standard date format SQL is year,
It is, although you don't have to enter it that way.
is it year, month, day?
Yeah. It's year, month, day, and then you can, but you can enter it. It's probably a good idea to get into the pattern of entering that, because when you get into MySQL and things, you have to enter it in that format. And to say that's a standard way to enter it is, yes, if when you set up your database, you say you're in the United States. Europe enters it differently. What is it? Europe is year, day, month. So it just reverses the two. We do year, month, day. They do year, whatever. I'm going to do a different version of this, which will give me kind of what I wanted in the beginning. So instead of equals, I'm going to use between, and then I'm going to say and 2015-08-12. And basically it'll give me all the stuff that happened on that day from 0 till the end of the day, right? And between is an operator. It's really useful. You don't have to use it just with dates, but it's really useful with dates, because it'll give you everything between these two things, and it is inclusive of both of the ends. But this will be 2015-08-12 colon 00 colon 00, right, for the time. You could also, if you really want, you could enter the exact time. If you were looking for an exact time. So I'm going to do this. And I think, so those are the ones that were entered. Notice they're all 8-11. So there's 3 of them for that date.
So by using between, you alleviate the time.
Right. The other way we would have to do it if I wanted, are they all at the same time? They're not. So it would be really hard unless you really wanted a very specific one. You would have to, let's do the second one. Uh, 20:00:35. It goes out to the nanosecond. 890. I think if I do this, it should actually give me that one record. If I actually got it, yeah, it does. So it's here.
Which one's most commonly used, which format, in between?
It's probably the between, or the other thing is if the time isn't what you're looking for, use the date format, not the date time, right? Date time is good here. It may not be for these queries, but date time is good here because it's basically a timestamp. Gives you the exact timestamp that the thing was done. So one of the other things I'll say about dates, I'm not going to show you a lot of functions because I don't think I need it. We need them for the assignment, but I will show you get date. That will give us the current date and time. One other thing I will show, because you might need it, I'm going to just select donation amount, and then I'm going to do donation amount.
You got in where there's,
Oh, here, yeah. Good eye. Donation amount times, let's say let's say like 65% goes to the actual charity of every donation. So I'm going to say from donation. The point of this is I want to show you you can do math. And I'm going to show you a couple of other things real quickly, and then we're going to join a table. I don't want to spend all day on this. If we do, I guess I'll give you next time to work on it. But so notice this is 157, this is 102. So it took 65% of this, I presume, is that. You can do math. It's just the operators are the same as the other languages. Asterisk is multiplication, plus is plus, minus is minus, slash is division. Modulus, I don't know if the percent works as a modulus. I'll have to try that at some point. Nothing that you're going to do requires that. But you can do all the math in here. And a lot of times when you're trying to sum things up, you want to do some math, right? So notice that this says no column name. And that's because it's a calculated column. And I just want to show you can alias things. So I'm going to say as charity percent or whatever. And when I run that now, it replaces the no column name with charity percent. And you can do that for any column, right? Even if it's not a calculated column, you can alias it if you want a more friendly name. So if you want a donation amount here, not to say donation amount, but just amount, you could say and it would change the column name in the output to amount. So you can alias any column. This is useful for reports, right? If you're making queries that are going to go out as reports. The as word is optional, by the way. You don't have to say as. Probably a good idea, just so you remember that's what you're doing, that you're aliasing it. But it'll work just fine without the as's. Yeah.
From this, would you be able to just create a new table, like, and insert that into your database?
No. There are ways to insert from a select, but you can't change the names while you do it. Does that make sense?
Yeah.
You can. There is actually an insert with a select. I might show that. So if you wanted to insert all the data from one table to another, you could. So the operators, again, I'll just comment. So there's asterisk for multiplication, plus, minus, division, and I'll check on the modulus. But again, there's nothing we're going to do that will need that. What else did I want to show you? What? Let me look before I go on, because what we will do, add to this when we go to, I want to go to,
It does modulus.
what?
It does modulus.
It does, okay, thank you. So I'm going to do Canvas. I just want to see what's in the assignment. I want to make sure I cover what's in the assignment. I don't want to cover too much beyond that for right now, because it would be too kind of overwhelming. It's interesting that the login now doesn't have the same look. All right, so let's go to 220. That's gigantic because I'm zoomed and it's zoomed. Maybe do a little bit. So let's go to assignments. Well, actually, let's do modules. And SQL Server, and this is under sample data and tests, and the SQL is for the tests. So I see this, there it is. So what I did is I wrote some questions, and the idea is to, what albums are in stock, who are the customers, so basic selects, what requests are currently pending, how many albums did you sell on X date, purchase a new album, so that's an insert, create a sale with a customer, so we'll do those. So there's not a lot here, but I do want to show you some joins and some inserts. If your database doesn't have a way to answer one of these questions, you could substitute one of your own. Does that make sense? Just tell me. We could, and I'll help you with them too, but I just wanted to make sure that I'm covering what I think we've covered most of what we need there, but there's a couple of things. I want to show you how to join tables, and I want to show you how to do an insert. And then, as I said, we'll expand on the SQL when we do the MySQL. All right, so one of the things we have when I do select star from donation, and I can do that by just doing that, selecting just it. We have like the person key here. If you wanted to see the person, you would have to get that from the person table, right? So let's do, I'm just going to do person. We're going to get the person last name. We'll keep maybe their email and then the donation amount. So let's do that real quickly. This is will be a little confusing, but it'll be useful. So I'm going to do select. So I'm going to do person, last name, person email. I'm going to do donation. Do I want just the amount or do we want the date too? Donate. Let's just do the amount. Donation amount. All right, so these come from two different tables. The person last name comes from one table in the email, and then the donation amount comes from another. So what I'm going to do is I'm going to say from one of the tables, and I'm going to say from person, and then I'm going to join it, and it's the type of join is an inner join. Most of your joins will be inner joins, but there are other kinds of joins. There are full joins, there are outer joins, there are lots of different kinds of joins. We're going to ignore most of those. We're just going to do inner join, yeah. A join, we're joining two different tables. Remember how in the design you split them all up, but you're going to want to see them brought back together when for forms and things. So the other table I'm using is donation. Right? Donation amount comes from donation. But there's another piece to this. I have to tell it how the two tables are related. So I'm going to say on, this is basically to say how they're related. I'm going to say person dot person key is equal to donation dot person key. So generally, though not always, this is primary key, foreign key, right? How do those tables relate to each other? So I can do this, and I can execute. Let's just do F5, I guess. And now I'm seeing the last name, email, and the donation amount. If we were to sort it, we would see that some people donated more than once, right?
Sorry, how do you get person key?
Person key is a field in person, right? It's the primary key in person.
Okay.
And it's the foreign key in, so I'm going to do a real quick show donation again. It's the foreign key in donation. So primary key in person, foreign key in donation. So when we run this, we're showing it how they relate, primary key to foreign key. Does that make sense?
Yeah.
This is part of why the keys matter. I mean, it's a way of connecting things, right? And you can bring it back. You can see what that person donated. And again, if we order it by, I'm just going to order by last name. Person last name. You could see some people like Johnson is given 2 times. Mann is given like 1, 2, 3, 4 times. Masters is given several times. Well, if you wanted to do a group by, so let's do one more of these. Usually that's only with aggregate functions. So we could do, if we wanted to know what the total donations were per each person, you could put like a sum there. But if you do that, then you have to group by person. I'm actually going to group by email first and then person last name. You have to group by everything that's not part of the sum. And order by, I guess, has to come after. This is not something in your assignment, but it gives you the total. So like Mann now has $2,500 total. It shows the total per person. One of the things to know about SQL, I'm not asking you to learn a lot of it right now, is it's really powerful for analyzing, you know, and grouping and summarizing and doing all sorts of things with the data. A database with just the data, you know, if all it was to store the data, it wouldn't be all that useful. It's only what you can do with the data when you pull it out that matters. So this is a join. I'm going to do one other table and show you a larger join. I don't think anything you're doing has to do that, but I'll show it. And then I'll show you inserts. And then I think we'll be have enough for the assignment. And I can give some time on Wednesday too. So I'm going to do, first I'm going to show you a table. I'm going to do select asterisk from grant request. All right. And so this is where people ask for a grant. And I wanted to show you it has 2 foreign keys. It has the person key and the grant type key. Does that make sense? Or the grant type is what kind of thing are they asking for? Here it has an explanation and then it has an amount. So I just want to show you, I'm going to do select person last name. And again, I'm really glad that it's not case sensitive. Person first name. I'm going to do grant request date. I'm going to break the line just to keep it on screen. I will do grant type name. And we'll do the grant request amount. All right, so I have fields from 3 different tables. So I just want to show you, you can do this again. You can do an inner join. So first we say from, and I'm going to start with person, although you don't have to. That gets the person last name, person first name. And then I'm going to do inner join grant request. And it's going to be joined on person.person key. Oops, space there. Equals grant request dot person key. Right, so person key in person relates to person key here. We're telling how the 2 tables relate. Now we have one more inner join to do because grant request type name isn't in either of those. So I'm going to do another inner join and grant type. And how do you know which tables? You just sort of have to look, ask me. I mean, in your own database, it'll be easier because you'll know what the tables have in them. But I'm just going to do grant type, and I'm going to do on grant type dot grant type key equals grant request dot grant type key. So again, I'm telling how the tables relate. There's a grant type key and grant type that's related to the grant type key here. And using that, as I said, the keys are in the background. If you're building software, you can write these things and they don't have to ever see the key, they just see the name. So I'm going to run that and we'll see the name. Right, first and last name, first name, we got the date, we got what kind of grant they're asking for, and the amount that they're asking. The code again?
Yeah.
What? Let me look. Grant type key. No, it's not. Oh, you need 2 keys in grant type. Yeah. Oh, that makes sense. So I'm going to post it all on the blog. So maybe you can copy it. But basically, I just showed you how to do it. So that one is good. Oh, yeah. So one of the queries, and I'm basically just showing this all the queries on the blog. So that we can look at. Yeah. You had another question? Somebody had a question. On means is how do they relate? So the on is a keyword that begins talking about the relationship. So we're saying what kind of join it is. We're joining it with a table, right? So you're bringing the tables back together. That's what the join means. And then we have to say how those tables relate to each other. And on is the key word that says that. It's on this key equals this key. And then because the key name is the same in both tables, I have to qualify it. So it's a table name dot column name, table name dot column name. And you wouldn't have to do that if you named your foreign keys different from your primary keys, but I think it's clearer not to. But it does mean you have to do this dot notation. So those are inner joins, and you can go on with as many inner joins as you need, right? So if you want to join 5 tables, you just keep doing inner joins until you've got all 5 tables. You want to, as long as there's a path of relationships between them, you can get data from any table you want into the same query. Does that make sense? So you can join for views and stuff for your forms and your web pages. You can bring all the data that we split apart for the design, you can bring back together for the users. It could be a fairly hairy statement sometimes, but it can be done. Anything can be retrieved. All right. So the last thing I want to do is do some inserts. Let me look and just see. Yeah, so it just needs create a sale. How many albums did you sell? To do how many albums you sold, let's go back to here. That would be using like a sum, right? Okay, so to insert a new, let's have a new person that's going to donate. So this will be worse than yours because of the way it's split up. But typically when you do this, there's a whole bunch of things. Like I have to insert, if it's a new person, I have to insert it into person, which is down here. I have to also insert it into person address, which is just down below here, and contact, if they have a phone that I do it to. So it's all split up into 3 tables plus the donation itself, right? So that's 4 tables. So I want to show you how to do an insert, and there's no way to insert into all 4 at once. You have to insert them one table at a time. So the syntax for insert is insert into, so we'll do insert into person. And I'm going to show you a quick cheat here. See how I'm grabbing the columns under here on person? Just going to drag that in. We can't insert into person key in mine because it's an auto number, right? It won't let you insert into an auto number. I'm going to break the fields so that they're all on screen. So you do insert into person, and then you list the fields you want to insert into. You do not have to insert into every field, and in fact, there's a couple of these I'm not going to do. I'm not going to do their password, and I'm not going to do password seed. Those would involve functions I don't want to get into right now. You do have to insert into everything that is not nullable. Notice I left everything nullable pretty much, right? So you can leave them out. But if you've made it not null, you have to insert into it. So once I've done that, I can do values. And in the values, I'm going to say, does anybody have a good name?
Richard.
What?
Richard.
Richard's for last name? Okay. First name? Keith. Email, I'm just going to kr@gmail. G. Again, it doesn't have to be a valid email, but, and then for the entry date, I think it has a default, but I'm going to just do get date. All right, and then we would also want to insert into address. And again, what I'm going to do is I'm going to go down to person address, I'm going to grab the columns folder, just drag it up here. It's kind of neat. We don't want the person address key because it's auto number, and I broke the line just to get it all on screen.
Question.
Yeah. What? So I grabbed the columns. Yeah, so if I just grab the columns folder, except I don't want person, I want person address. Just drop it. And then I'm breaking the lines just to be on screen. Actually, I'm going to leave apartment out because it's nullable. And I'm not going to put city or state because they have defaults, just to make it easier to enter. And how do I know that? You'd either have to look over here. So when I look at columns here, shows me the values. They're all nullable except for the key. For constraints, I've got some defaults, but it doesn't show what they are exactly, but they're for city and state. So the address street, I'm just going to do 1000 somewhere. Boulevard. Seems like somewhere should be a boulevard. Zip code 98122, which is right here. And then the person key, we don't know what the person key is or what it's going to be for sure because we haven't inserted the person yet, right? There's a couple of things you can do. Yeah. Sure. We need the person key, but that person hasn't been installed or inserted yet. So there's a couple of ways you could do it. One is you could insert the person and then go look for the key, right? Or there's a function you can use, which is ident current. And I'm going to do this, I'm going to say person. What ident current does is it returns the last auto number generated in person, right? Which should be that one, right? Because we're going to insert that. It will generate an auto number. This will return that auto number as the key, which should be the right key. Couple things about this. This doesn't work if you don't have auto numbers. Then you just, well, then you'll have to enter the person key anyway, so you'll know what it is. Right? If it's not an auto-generated key, you'll know what it is because you have to insert it. But this will return the last auto number if you use an auto numbers. And it tells you which table it's returning it from. So when we run these, it'll do this one, it'll generate the number, it'll put that number here. Does that make sense? Sort of. I'm going to, the other place we have to insert is into contact, although we could skip that. That's for phone numbers. And the reason why there's a table is that you could list several phone numbers for any one person. Do we want to insert into phone numbers? We could skip it. Let's insert into donation now. And again, I can, if I want, go over here to donation, grab the columns and just put that in there. We need the person key again. We need the donation date. Although I think that's auto. We need the amount. And I think the confirmation is automatically entered. So let's kill that. I'm just going to do values. Person key, I can do exactly the same thing. I'm going to do a comma. We need the date. I'm just going to do get date. As I said, I think that's the default anyway, but then I'm going to do the donation amount. How much do we want to donate?
$5,000.
Wow, okay. You don't have to do the zeros, but all right, so that's our thing. So let's just run this. I'm going to run all of them together. You could run them one at a time if you want to. I'm going to execute that. Notice it just has one row affected, one row affected, one row affected. So the way you find out, I'm going to do select asterisk from person. And I'm going to go all the way to the bottom. And notice we've got Keith Richards. And it's null for that because we didn't do that. Right? We left out the password. Sometime maybe if we have time, I'll show you how to use the functions that I wrote for those. Okay, so they're there. And their number is 130 on mine. It could be different on yours, but probably not. I'm going to do select star from person address. And we'll go to the bottom there. Come on, all the way to the bottom. Okay, so 1000 somewhere Boulevard, and then the person key is 130. So it made that connection, right? I have an address with that person. And the key is 130, so it's tied to that person. And then I'm going to just do a select star from donation. Go down to the bottom, and 130 is the person, 5,000, and it generated the confirmation key. So that's the inserts. And it's really typical. Let me kind of lower this and bring this up. It's really typical that you have to do multiple inserts because of the way tables are divided up. Think of your sale detail, right? If you have a new person and they want to enter their information, you'd have to insert in the client, in the sale, and then in the sale detail. So you'd have to insert into 3 places. If it's a new person selling to you, you'd have to do the same thing, right? You'd have to insert the client, the seller information, the purchase, and then the purchase detail, and then into inventory too, for that matter. So inserting into multiple tables is fairly common. I think that gives you all that you need, and I have left you a lot less time than I meant to. What we will do on Wednesday will be mostly Open Lab. But in addition to the Open Lab, we'll also download and install MySQL. I think you could do it and work on the other thing at the same time. So the point of the SQL is partially to teach you the SQL and also to show you how to use the database a little bit. Okay. And I'm going to post all of this online on the blog. So if you didn't get it typed in or you're just watching, it'll be there for you to play with, and you're welcome to expand beyond it too if you want. Questions? Yeah. Okay. Oh, no, I think you stopped. What did you just do? Yeah, yeah. So I'm going to post all of this right now. I'm also going to stop the video now, so it doesn't have quite so long a dead tail. Just need to get out of